Okay, but so we are going to discuss the covalent bond today. In the previous class, we have gone through that how it decides that which type of bond is going to be formed. The electronegativity difference decides what type of bond formed between two atoms. If the electronegativity difference is greater than 1.7 between two atoms, so their bond will be ionic. If the electronegativity difference is less than 1.7, then the bond will be covalent. And the covalent bond is the bond which is formed by sharing of electrons when electronegativity difference is less between two atoms. This is how it is formed. It is not precisely the definition, bacho. If he asks you to define, then definition is the bond in which the nucleus is the force of attraction. The bond, the covalent bond is the force of attraction between nucleus of an atom and the electrons of other atoms. So this is the definition, the textbook definition of the covalent bond. When he asks you to define, you have to write this. Okay? This is the textbook definition of this, right? When he asks you to define, you have to write this. It is the force of attraction between the nucleus of one atom and the electrons of other atom. So actually they cross attract each other. This is the bond. Now let's show the dot and cross diagrams. We show the bonding in the following molecules. For example, number 1, hydrogen gas. How the bond is formed between two hydrogen atoms? We all know. Hydrogen is in group 1, having 1 electron, right? And hydrogen's first shell is the valence shell, okay? And then there is another hydrogen having 1 electron in the valence shell, okay? So how they are going to form a covalent bond? Yes. They will overlap, they will share, right? And both of them will have 2 electrons in the valence shell, which they need because the first shell is the valence shell. So they are going to form like this. Here is the 1 hydrogen, here is the 1. So both these hydrogen, they share their electron here. So putting this electron pair in the center mean, now it belongs to both of them. And here is the single bond formed between these two. Okay?
There's still giant lattice friction?
No. Structure I'll explain in the second part. And this thing, H2, this is the one molecule that is formed. And this molecule, you can see it's a small molecule, consists of 2 atoms, so it can't be giant. Giant is only when they have so many atoms joined together to give you a big number, which is not countable. Okay? Obviously, this is a small molecule having 2 atoms joined together. So it's a simple molecular structure, but I'll explain the structure in the next part. Number 2, the chlorine gas. With the help of dot and cross, we have to show the bonding in Cl2. This is one atom of chlorine having how many electrons? 7. There is another atom of chlorine having 7. So they are going to share one electron. Here is the shared pair of electron which belongs to both of them. Here it is. And this shared pair of electron, bacho, is known as bond pair. We call it bond pair of electron or bonding pair of electron. And you see there are other atoms in the valence shell of the chlorine molecule with each atom of chlorine, which are there, but they are not involved in the bonding. They are known as lone pair of electron. Okay, or non-bonding pairs. This is the term which you need to learn. Non-bonding pairs. So Cl2 molecule has one bond pair and 6 lone pairs, 3 with each chlorine. Okay. Number 3 is oxygen gas. This is all the O2, so I'm just going through it quickly, bacho. Oxygen has 1, 2, 3, 4, 5, 6 electrons, so it needs 2 more to complete its octet, or having 8 electron in the valence shell. So they are going to combine with another oxygen like this. And now in this case, there are 2 covalent bonds formed between 2 oxygen atoms. Because 6 electrons, they one, if it could have shared 1 electron, so 7 electrons won't make or won't serve the purpose, right? So they have to complete 8 electrons in their outer shell, right? Hence, you see there are 2 electron pairs that are shared. This is known as double covalent bond. Okay, there are 2 shared pair of electrons known as double covalent bond. If you look at the bond pairs, there are 2. If you look at the lone pairs, there are 4. 2 with each oxygen. Similarly, nitrogen gas, N2. Nitrogen is in group 5. 1, 2, 3, 4, 5. How many electrons it still needs? 3. So it's going to share 3 electrons like this. How many bond pairs? 3. How many lone pairs? 2 lone pairs. This is N2. If you look at the methane, what about this? CH4. Carbon is having 1, 2, 3, 4 electrons in the valence shell. When you have a molecule like this, which is not diatomic, having more than 1 atoms, so in order to show the dot and cross, once you are sure that it's a covalent bond, first write the central atom, the single atom. Like in this case, out of CH4, carbon is the single atom. So first I write this, and then I see how many valence electrons in the carbon. There are 4, so carbon needs how many more? 4 more. Hydrogen can share 1 because its outer shell is the first shell. So it goes like this. So what is this now? CH4. Okay. How many bond pairs? No lone pair. Okay. 0. Now I would like you to lead, bacho. Before I go on, I would like you to lead. Okay. I'll do it, but after you. Number 7 is water, because this is all the O levels. So I don't want to skip it, but I want you to do it. Please mention the lone pair and bond pairs. Bonding we started in the previous lecture, which was electronegativity and ionic bond. Today we started with the covalent bond. We have to draw the dot and cross diagrams along with the displayed formulas representing how many bond pair and how many lone pairs are present in this molecule. We are studying the covalent bonds, but they have the simple molecules consisting of 2, 3, 4 atoms together to make a tiny molecules. This structure is known as covalent bond and simple molecular structure. So today we are going through them. Okay. I on purpose stopped for the ammonia, water, carbon dioxide, ethane, hydrogen, and ethene for you to lead. Can anyone help me with ammonia? Ji? Yes, go ahead. Ammonia. Okay, so first, in order to draw the ammonia, I have to write nitrogen first. It's a single atom. Nitrogen is in group 5. So 1, 2, 3, 4, 5 electron. It still needs how many? So 3 hydrogens. As hydrogen can share only one because its outer shell is first shell, already having 1 electron, so one more it needs. Here it is. So this is NH3. How many bond pairs? Bond pairs. And how many lone pairs? One. That is with the nitrogen or with the hydrogen? Nitrogen, the central atom of the molecule. Just single atom होता है, we call it central atom of the molecule. Can somebody help me with the water again? Okay, oxygen is having 1, 2, 3, 4, 5, 6 valence electrons. How many it needs? So one hydrogen shares on this side, one hydrogen on this side. Right. So two bond pairs and two lone pairs. This bond pair, lone pair counting, we need it because in the next part we'll be using it. Okay. So that's why I'm asking you to do it. Carbon dioxide. What about the carbon dioxide? So first I write carbon having 4 electrons in the outer shell still needs how many? 4. One oxygen can share 2. So one oxygen comes on this side, shares its 2 electron. That also completes the oxygen's octet. And one oxygen comes on this side, shares 2 electron, and that also completes its octet. Right? Yes. Two bond pair on each side. So four bond pairs and how many lone pairs? Four lone pairs. There's no lone pair with oxygen, with the carbon, two lone pairs with each oxygen. Okay? What about ethane? Now, once you see that the central atom is also having two atoms together, so we understand this, okay, first they should be bonded together, like there is a carbon and there is a carbon. So many carbon ko I joined them together by one single bond, okay? Like this. Now each carbon has how many electrons? 4 plus 1, 5. Still needs how many? 3. Do I have 6 hydrogen to share? 3 on this side, 3 on this side? Yes, I do. Here it is. Okay? So C, this is H, this is H, this is H, and similarly, got it? 6 bond pairs or 7 bond pairs. How many? 7. And lone pair? No lone. Hydrazine. Anyone for the hydrazine? N2H4. Yes.
Triple bond with the nitrogen.
No, nitrogen is having 1, 2, 3, 4, 5 electrons. If this is N2H4, so the rule is first just attach two hydrogens, two nitrogens together, okay? That will make how many electrons with the nitrogen? 6. Still needs how many? So do I have two hydrogens to share electrons? So why would it make triple bond? It can't make a triple bond. Okay, if two nitrogens make triple bond with each other, they won't need any hydrogen anymore. So that will become N2, not N2H4. Okay, look, if I draw it like this, 1, 2, 3, 1, 2, 3. So now, do you think these nitrogens still needs anyone? They have 8 electrons, so they can't have N2H4. This is for N2 only. Okay, so N2H4 is having single bond between two nitrogen atoms. Here, how many bond pairs? 4. And how many lone pairs? 1 with each nitrogen. Okay. What about ethene? C2H4. Hydrazine is 1, 2, 3, 4, 5. Yeah, 5 bond pairs, 2 lone pairs. Ethene G. Yes, here the situation is slightly different because carbon is having 1, 2, 3, 4 electrons. If two hydrogens come on this side, so that will make carbon's electron 6. That won't complete the carbon's 8 electrons. So in order to complete the 8 electrons, carbon has to share 2 electron on this side. Okay? So it's what? It's a double covalent bond. So how many bond pairs? And how many lone pairs? No lone pair. This is known as double covalent bond, right? So this was the mostly the O level stuff. So I just pass through it quickly, right? So now we are moving on to a bit A level stuff. But the same dot and cross diagram, we have to explain the bonding, the covalent bonding precisely with the what structure? Simple molecular structure. Simple molecular structure in which we have to justify the formation of tiny molecules with 2 atoms, 3 atoms, 4 atoms, or something like this, which are the countable.
Second, make the structure of Cn minus.
Yeah, I'm gonna make the hydroxide ion in both. Okay. Now 12 is hydroxide ion. Now, but your first thing first, whenever you are looking, I know this is a covalent bond. So first thing first, what is the meaning of this negative charge? It has one extra electron. Okay, so I'll keep it in my mind, but I'm not going to use it first of all. Okay, first of all, I'm going to justify how the hydrogen and oxygen can share their electrons. Okay, oxygen is having 1, 2, 3, 4, 5, 6, and it shares one electron with the hydrogen because hydrogen has only one electron. Now, hydrogens doublet is complete. The hydrogen's valence shell is complete because it can have two electrons, and now those two electrons are there for the hydrogen. But oxygen had seven, had six, and now how many? But high oxygen's octet is yet to be completed. So that now gives me an idea that one negative charge that I see on the top, that tells me this is an extra electron. Now I got to know that extra electron must be with what? Oxygen, not with the hydrogen. Sometimes students think a negative charge is on the top of the hydrogen, so they put extra electron with the hydrogen. No, don't do that. Okay? That extra electron must be with the oxygen. And for the sake of clarity, I'm showing that extra electron with the square. Okay? Now this is OH negative. That's why. Okay, now how many, just one last question. How many bond pairs? One. And how many lone pairs? Three. Okay, now there are three bond lone pairs and one bond pair. Yes, yes, go ahead.
Then why we are putting a square?
No, it's just to distinguish. If you don't want to put a square, so you can put a dot like this.
I just want to.
Yeah, it's okay. You can put it square or anything. You need to distinguish between them. Okay. So this is, look at this. Now I have to distinguish. I did this extra electron. I hope you understand. Just to make sure that this does not belong to oxygen. Anyway, you have to show it. Okay, Cn negative. Now I know this negative charge is an extra electron, but initially I'm not going to decide that extra electron is with carbon or nitrogen. Okay, first I have to make a bonds between carbon and nitrogen. Okay, see, carbon has 1, 2, 3, 4 electron in its valence shell. Nitrogen has 1, 2, 3 electrons it shares. So nitrogen's octet is complete now. Is it so? How many electrons with the nitrogen now? With the carbon now?
So it's a.
Still needs one. So that extra electron, which we knew that came to Cn from some metal or anywhere, don't follow that electron. At this moment, we know there's an extra electron. So that extra electron must be with what? Carbon. That's why it is Cn negative. So how many bond pairs? And how many lone pairs? Okay. So this is how you write Cn negative, the dot and cross diagram to show the bonding in Cn negative. Now I'm giving you another. That is O22 negative, bacho. O22 negative. Please give it a shot. O22 negative. Show the bonding in O22 negative.
Oxygen, then a pair above and pair on the left, and then one electron is being shared and one electron is on the downside.
It has gained.
And then it gains one each.
Oxygen is in group 6 having 1, 2, 3, 4, 6 electrons. Is it so?
Yes.
There is another oxygen having 1, 2, 3, 4, 6 electrons. If the oxygen share one each, then they are going to have how many electrons? 7. They still need one each.
Yeah.
And that 2 negative already told me that they must be accommodating the 2 electrons. So one of the electron will be with one oxygen here, and other will be here. So now oxygen is a single bond with oxygen. How many bond pairs then? 1. And how many lone pairs? And lone pairs are 3 and 3, 6. Is it clear? Now I'm gonna draw a rough sketch of the periodic table here before I continue the next dot and cross diagrams. Again, for the sake of reminder, what we are discussing, the covalent bonds and the compounds with what structure? Simple molecular structure in which 2, 3, 4, 5 atoms combine to make a tiny molecule. And today we are doing the dot and cross diagrams to show the joining of those, making of those tiny molecules. Okay. Now, before I go on, I have to sketch a rough sketch of the periodic table. This is hydrogen, helium. This is lithium, sodium, no, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Just 1 minute. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. And then potassium and calcium. Yes, go ahead.
How can we know that there is double bond and triple bond?
We have to, we don't have to worry about it, because what we have to do, just complete the 8 electrons in the outermost shell and see how many electrons they have to share to get that thing done. For example, in this case, what we did, we were just looking at oxygen's electron. They were 6. Now we need, oxygen needs how many electrons to complete? 2 to get 8. So if other oxygen comes and shares 1 electron, so that will be 7, not. And on the other hand, I know that there are 2 extra electrons are also gained by this. So that's why I put 1 electron on this side, 1 electron on this side. In this way, it get negative charge on this and negative charge on this. Right? So this is how we look at that. Yes?
Sir, the question, can you go to the structure of C and negative? Yes, sir. I see you have written that one pair of P. So there are 4.
Which one is fourth one?
Sir,
That's a lone pair. The one that has gained carbon, that's not the bond pair, that's a lone pair. You see in OH negative, we also considered it a lone pair. The one that has gained by the oxygen or by the carbon in this particular case, this is not taking part in any kind of bonding.
so not, but the bond that are in between them, the carbon.
Here is the bond pair, here's the bond pair, here's the bond pair. Here is the lone pair, and here is the lone pair. Okay. Okay, now look at this periodic table. You are not supposed to draw. I have to make a point. That's why I'm drawing this periodic table here. Listen. Now, if I take these 2 elements here, which I highlighted, one is nitrogen and another one is phosphorus. You must know that period 1 has only 1 shell. I hope you know this. Period 2 elements has how many shells? And period 3 has how many? As you go down, you know number of shells are being added. Okay, now I'm going to take these 2. Right? They are the group 5 elements. One is nitrogen and one is phosphorus. If I draw the atom of nitrogen, first shell having 2 electrons, second shell having 5 electrons. Okay? If I draw an atom of phosphorus, as I told you, it has how many shells? 3. The first shell has how many electrons? 2. The second shell has how many electrons? 8. And third shell has how many electrons? 5. So although the 5 electrons in the valence shell of nitrogen and 5 electrons in the valence shell of phosphorus, but phosphorus ke shells are 3 quantum shells and nitrogen shells are 2. Now let's see, we have a lot of chlorine atoms and we want to share the chlorine electrons together. What to do? If one chlorine comes here, shares its electron, one here, one here. That makes what? NCl3. Does the nitrogen's octet is completed? This is NCl3. How many electrons now nitrogen has in the valence shell? Okay. This is known as its octet is complete now. Okay. Now come to the other side, the phosphorus. Yeah. If you look at the phosphorus, three chlorine come here, one, two, and then three. Okay. How many electrons now this phosphorus has? 8. Its octet is also complete. Now listen carefully. And this becomes NCl3 and this becomes what? PCl3. Now listen carefully what I'm trying to do. Now, can you see the lone pair of electron in both these, nitrogen and phosphorus? If an atom of nitrogen wants to use these electrons to go into the bonding with any other atom or with two more atoms of chlorine, for example, the nitrogen cannot, even if it wants to. Why? Because it's not that the nitrogen has got the stability as it has adopted the shape of noble gas. The nitrogen's outer shell has a capacity of 8 electrons, because if you can notice, the nitrogen's outer shell is the second shell. So if I look at 2n square, so 2 raised to power 2, 2 times 4 is equal to 8. So even nitrogen, if wants, can't use these two electrons to make covalent bond with two more nitrogen atoms. So NCl3 is there. That's the end of the story for the nitrogen. But on the other hand, if you look at the chlorine, phosphorus, it can still go like this. It can use this electron to attach two more chlorine with it. And it will become PCl what? 5. This is called expansion of octet. Why? Because the phosphorus, why phosphorus can use these two electrons to attach two more chlorines, and why nitrogen cannot? Because the nitrogen's outer shell is second shell. It has already 8 electrons, and second shell has been filled up to the capacity. So nitrogen chahe bhi to cannot expand its octet. On the other hand, its octet is completed although. But if you look at the capacity of the outer shell, 2, 3 square is what? 18. So phosphorus outer shell is the third shell. So it can place how many electrons? Up to 18. So therefore, the phosphorus can use its all of the electrons to go into the bonding and make it PCl5, right? So this is called expansion of octet. So what I'm trying to say here, and why I draw the periodic table, because it means all the period 2 elements, this is period 2 bacho, all the period 2 elements have their outer shell, which shell? Second shell. So it means if they even want, they cannot place more than 8 electrons in their outer shell. Even if they want, they cannot expand their octets, right? Otherwise, anyone who is down, like period 3, period 4, period 5, period 6, period 7, their outer shell are either third, fourth, fifth, sixth, and so on. They can place as much electrons as they want. I mean, as much electrons they have in their outer shell, so they can just pair them up. So it means if I use the same logic here, oxygen's outer shell. Let's talk about oxygen and sulfur. Oxygen, just one last thing. Oxygen's outer shell is the second shell. Oxygen has how many electrons? 6. Oxygen cannot make it 12. 6 mean using all of them to make it 12, which it cannot. Why? Because its outer shell is what? Second shell, which has the capacity of what? 8 electrons. So oxygen has to inevitably leave its electrons. That's why once you see when oxygen makes a covalent bond with water, with hydrogen, it has to leave how many lone pairs? 2 lone pairs, 4 electrons. On the other hand, if you talk about the sulfur outer shell is a third shell having how many electrons? 6. 1, 2, 3, 4, 5, 6. It can, combine with 6 fluorines to make what? SF6. How many electrons in total? The outer shell? 12. So from now onward, instead of O levels, from now onward, what you are going to think, it's not about the making 8. It's what? An atom having 6 electrons, 5 electrons, 4 electrons in the outer shell wants to go every electron into the bonding. They don't want to be the lone pair. Okay, but there are some restrictions. The period 2 elements cannot do that. Why they cannot do that? Because their outer shell is second shell, and this is phenomena of octet expansion. इसी तरह इधर आ जाइए. If I take fluorine and chlorine, what do you think about this? Fluorine's outer shell is having 7 electrons, bacho. 1, 2, 3, 4, 5, 6, 7. What do you think? Can it make 7 times 2, 14? Why not? But on the other hand, chlorine can. On the other hand, bromine can. Even on the other hand, iodine can. For example, I can give you an example of IF7, in which you can just think of the iodine 7 electrons have gone into the bonding with the 7th fluorine to make IF7. Having how many total electrons in the valence shell? 7 times 2 is what? 14 electrons. I hope you got my point. This phenomena is known as octet expansion. I'm going to dictate it. I'm going to make you write all this. First, you need to understand. So from here onward, once you are drawing the dot and cross diagram, just give me 1 minute. From here on, once you are drawing the dot and cross diagrams, you are not going to limit yourself with the 8 electrons, right? You will try to utilize all the electrons in the valence shell of an atom and go into the bonding until unless the atom is not the group period 2 or period 1. Period 1 तो वैसे ही 2 कर सकते हैं ना, उनका valence shell is the first shell. No, it can make, they turn into a compound where they have the stability. But obviously, maximum stability is 8. More than that is less, less than that is less. Okay? So, but the idea behind, I hope you understand, is not about making 8, is about using all the electrons in the valence shell into the bonding. Right? So, आप लिख दीजिए expansion of octet.
Sir, you have to platinum consider every time you go there.
Yes, they must use all these electrons. Okay, please give the heading expansion of octet. So placing more than 8 electrons in the valence shell is known as octet expansion. Okay, we are going to prove it by drawing the dot and cross diagrams. For example, I'm going to write, you have to do this in homework. We'll discuss them tomorrow. Okay, so ICl3, PCl5, IF7, sulfur dioxide, BF5, XCF4, okay, this is the homework. You have to draw the dot and cross diagram for all these molecules. We are going to continue with this tomorrow, right? So I hope it's clear that what is the expansion of octet and which atoms in the periodic table cannot expand their octets, right? So that was all about the covalent bond, simple molecular structure, and how their dot and cross are justified, even using the octet expansion. Thank you very much. That's all.